with an important distinction between two things that we're going to talk about a lot this year: equations and expressions. And it's really important to know the difference between the two. I'll start with an expression. An expression is any series of math operations. An operation in math are all the things you're used to: adding, subtracting, multiplying, dividing. We'll learn a bunch more this year also. It can be a combination of multiplication and subtraction with addition worked in. It doesn't matter what's there. As long as all you have are operations, then you're going to use the word expression to describe what you see. There can be variables or unknowns in an expression also. Our job with an expression is going to be just to evaluate or simplify. Those are the two pieces of directions you might see for an expression. For example, we would be told to evaluate this expression using the order of operations you've learned before. We know there's subtraction in here, but multiplication comes first. And we know that before we subtract, we would have to do what's grouped, do the parentheses. And then we can subtract and say 24 minus 11 is 13. That's an example of working with an expression. An equation, you will not be surprised to learn, is a little bit different because an equation will have an equal sign in it. Something simple like 3x equals 9. That's an equation. The whole point changes drastically when you have an equation in it. In an equation, you will usually have an unknown, sometimes called an unknown constant. I'm talking about this x here. And your job in an equation is to solve. So let me write here what we did with an expression is we evaluate or simplify. And for an equation, our job is to solve. And when you solve an equation, what you're doing is finding the value of the unknown. In this case, we're going to find out what x has to be. And you know how to do this by dividing both sides by 3. We'll see lots more things like this throughout the year, but that's the goal. Okay. Keep that in the back of your minds because we're going to be using it a lot all year, including today. Next up, though, we'll talk about something which you may be familiar with, but it's totally fine if you're not. It's called an absolute value. Absolute value is a funny little idea. It is a number's distance from 0. It's a strange concept to talk about distance when we're talking about math. A good way to visualize it is on a number line. So if we imagine drawing a number line, the absolute value of any number is the distance on that number line. So if I were to put the number 4 up here and say, what is the distance between 0 and 4? Well, this distance is 4. That's not that complicated. Some of you may be familiar with the symbol for absolute value. It is 2 bars with a number or an expression inside of it. So the absolute value of 4 would be written like that. If you've never seen that before, that's okay. And the absolute value of 4 is simply 4. But what's a little bit interesting is if I try and talk about the absolute value of a negative number, like -2, the absolute value of -2 would be that distance between 0 and -2, which is also positive because it's measuring a distance. So the absolute value of -2 is also a positive number. It's 2. And so that's the important thing to note about absolute value, is that absolute value is always positive. That doesn't mean you can only take the absolute value of a positive number. Notice the difference in language there. The absolute value is positive means that the answer, the result of absolute value, is always going to be positive. But you can take the absolute value of a negative number. And just a couple of things to think about here. Because an absolute value is always positive, and because the absolute value of a positive number and a negative number, like the absolute value of positive 4 and the absolute value of negative 4, might end up being the same thing, we run into an interesting situation where if I tell you that the absolute value of some number, down here right now, the absolute value of x, some unknown number, is equal to 4. Well, what we said before is when you have an equation with an unknown in it, you solve it and you figure out what that unknown has to be. But you run into an interesting twist here, where if you say the absolute value of some unknown number is 4, I don't know if it's positive 4, that unknown number is positive 4, or negative 4. So we end up with a situation where an equation has two different solutions. And that's sort of what we've been building towards. That's the point so far. When you have an absolute value inside of an equation, or what we call an absolute value equation, you might end up with more than one solution. Let's talk about how to solve those absolute values. I break it down into 3 steps. Don't worry about those important notes yet. They'll be important in a minute. So the first thing you're always going to do for an absolute value equation, you know what, it helps if we actually start with an absolute value equation, so you know what I'm talking about. The absolute value of 2x plus 6 minus 5 equals 11. And just like the simple equation above, 3x equals 9, we solved for that unknown to find out what x has to equal. We're going to do the same thing here. Move this over a bit. So we're going to do it in 3 steps. Step number 1 is we are going to isolate the absolute value. Whenever we say isolate, and we're going to say it a lot this year, it just means get something by itself. And we're going to do that using all of the tricks you've learned in Algebra 1. If you want to get that absolute value by itself, well, there's a minus 5 on the same side of the same expression, the same side of the equal sign. Well, we just need to do the opposite of minus 5 to both sides, and that will get the absolute value by itself. That's our goal. So now the absolute value of 2x plus 6 must equal 16. That's step number 1. Done. Wasn't too hard. Sometimes you'll actually be given problems where that step's already done for you. Step number 2, and this is something you have to write out. You can't just skip this. But we're going to separate the absolute value equation into 2 regular equations. Just like we set up here, that if the absolute value of x equals 4, x could equal 4, or x could equal negative 4, we're going to do the same thing below. If the absolute value of 2x plus 6 equals 16, that means that 2x plus 6 could equal 16, or 2x plus 6 could equal negative 16. Those are the 2 possibilities. And the last piece here is the easy piece for most everybody, which is just solve. Now that we've broken it down into 2 regular equations, what we'll call linear equations, because there's no more absolute value. And that's very important that when we do the separating, notice how these absolute value bars, they disappeared, they're gone. That's important. So now we can solve, same way we always would. Subtract 6 from both sides, and then divide by 2 on both sides. And then we'll do the same thing on the other side. Subtract 6 from both sides. Notice how when I subtract 6 from negative 16, it's not the same thing as subtracting 6 from positive 16. And divide both sides by 2. X equals negative 11. And those are my 2 solutions. You can leave it like that, x equals 5 or x equals negative 11. There's a fancy way to write this. When we have more than one possible answer, that group of numbers is called a set. And you can use set notation if you'd like. And I want to point out these important notes over here. We always need to finish isolating before we take away the absolute value bars. That is very important. Don't try and skip that step. And then when you do the separating, make sure you separate side by side like I did here, where it's one and then the other. Don't get into a habit where you're doing things like this. 2x plus 6 equals 16, blah, 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 solve. And then 2x plus 6 equals negative 16, blah, blah, solve. It breaks a couple of math rules, which we'll get into a little bit later. We're not going to talk about today, but don't get into that habit now so that way you don't end up breaking those rules. Okay, the next thing we're going to look at quickly are a couple of strange cases, a couple of exceptions. Number one, and the name kind of gives away what's going to happen, the impossible case. If we go through our steps for this absolute value equation, the absolute value of 2x minus 3 plus 12 equals 7, our first step should be to isolate. So that's what I'm going to do. Isolate. You know what? I'll stick to my colors. Isolate's in blue. Notice how I'm not done isolating until I've written it out with the absolute value isolated. Now I can think about separating. But here's the catch. I want you to notice before you get to separating, and every time you're doing their absolute value equations, and solving them, before you separate, think about this just to make sure, can the absolute value of 2x minus 3 actually ever equal negative 5? No. No absolute value is ever going to equal negative 5 because we said a few minutes ago an absolute value is always positive because it's a distance. So we can say right now that there is no solution. And that would be your answer. There are a couple of ways to write that also. You can use this symbol, not 0, but that symbol, or you can draw the empty set. But to be honest, I think it's better if you just use the simple, easy, no solution as your answer. Okay. The other example here is a little bit trickier. So take a look at this equation and see what looks different about it. The absolute value of 3x plus 3 minus 21 equals 5x. You might have noticed that there appears to be something extra here. There appears to be an extra x. That unknown shows up a second time. When that happens, you need to beware. Be careful. The process is the same. I'm still going to isolate, separate, solve. So let's do that. Isolate. Add 21 to both sides. Of course, like you learned in Algebra 1, when you add 21 to that right-hand side there, you're going to be careful. You can't add 5 plus 21 to make 26 because the 5 has an x. They're not like terms. So I'm simply going to write 5x plus 21. Okay, that's my isolate step. My separate step. When we do our separating, it's the same rule as before. If the absolute value of 3x plus 3 equals 5x plus 21, whatever that is, I don't quite know yet, well, that means that 3x plus 3 by itself is either equal to 5x plus 21, in which case its absolute value would be 5x plus 21, or 3x plus 3 could be equal to the opposite of 5x plus 21, which would be negative 5x minus 21. I want you to notice that what happened here, and if you want to write it out this way first, that's fine, is I took the opposite of 5x plus 21. And that's where that minus 5x minus 21 came from. So do be careful when you start having expressions up across from the absolute value that are more than one term, because you do have to be careful about when you separate and when you take the opposite of one side. From there, we're going to solve, just like before. You might remember from Algebra 1, when you've got x's on both sides, the first thing you're going to do is move them around so you can isolate the x's. I prefer to keep my x's positive, so I'm going to move 3x over to the left. I'm sorry, from the left to the right. If you would have subtracted 5x from both sides because you like seeing your x's on the left-hand side, that's fine also. And then I'll subtract the 21 from both sides. And divide by 2. So x equals negative 9. Remember, it's an or. I've got two possibilities here. I'm going to add the 5x to both sides. And then I want to subtract the 3. Going back to basic Algebra 1 solving rules. 8x equals negative 24, and so x equals negative 3. Just like before, we have two solutions, except this isn't actually true, at least not both of them. Whenever we have that extra x, I'm going to need to check for an extraneous solution. And you might remember this from Algebra 1. When you check a solution, what you do is we're saying that this x, this unknown number, has to be negative 9 or negative 3. Well, let's see. If x is really negative 9, does the equation work? Is the absolute value of 3 times negative 9 plus 3 minus 21 really equal to 5 times the absolute value of negative 9? Well, we can do the math here. The absolute 3 times negative 9 is negative 27, plus 3 is negative 24. So the absolute value of negative 24 minus 21 equals 5 times negative 9 is negative 45. And wait a second. Negative 24 minus 21 is negative 45. That's true. But the absolute value of negative 24 is positive 24. And then when I subtract 3 from that, I get 3 equals negative 45. And that's not true, which means that x can't actually equal negative 9. And so this is what we call an extraneous solution. An extraneous solution is a solution, or a possible solution, meaning you followed all the steps to get a solution and you got a possible solution that does not actually work. It means you didn't make a mistake, but that possible solution is not a solution. On the other hand, if we do a quick check with the negative 3, the absolute value of 3 times negative 3 plus 3 minus 21 equals 5 times negative 3. The absolute value of negative 9 plus 3, so that's a absolute value of negative 6 minus 21 equals negative 15. And this does take me just a second to expand my page here. And I can check this out. The absolute value of negative 6 is 6. 6 minus 21 is negative 15, so this one does work, which means x minus equals negative 3 is a solution, x equals negative 9 is not.